Hi students, I have started streaming. Let's check as usual if I am live. I can't see myself live right now. It takes some time, okay? So, not yet, not yet, not yet. Why is it happening? Quick, 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 quick. Still, I can't. Just let me see. Yes, I am live, beta. Now I am live. Now I'm live. Let me share the link quickly on the Telegram group. Okay. So yeah, here is the I have shared the link on Telegram as well. So yeah, guys, let's get started. As you guys know, this is Unacademy, right? This is Unacademy ICSC and ISC both channel, correct? So yeah, let's get started. We have met after, I believe, 2 or 3 days, right? Okay. So I would say that we will ace in your term 2 examinations with Unacademy Plus, right? And you will get additional 10% off if you get plus subscription, and if you use my code you will get the extra 10% off. Okay, yeah, it's working. So let's move ahead. Very official our introduction. So you know that I am your chemistry educator Kirti Sharma, and I am your chemistry educator. I have done my graduation from University of Delhi, and I have taught a lot of students like you and smart like you. So now it's your turn, and I would say to share the session, to share the channel, to spread the news that now this category has been opened here, because a lot of students don't even know that this category has already been opened. Okay, it has been launched. A lot of students don't even know about this, so it will be very beneficial if you guys help us. So let's move ahead. Now, what will we study today? As you can also see, my code my YT code is Kirti S Live. This is my code. And when you open an Academy app, okay, when you play it from when you download it from Play Store, okay, so it will ask you whenever you want to, for the very first time, when you want to unlock a free live class, it will ask you to unlock it. So there you can use this code. It is Kirti S Live. Please remember, it is not Kriti, it's Kirti, okay, Kirti, Kirti S Live. And if you are planning to get the plus subscription, then get it, and you will get an additional 10% discount. Okay, I have one more scheme for you. I will let you know today. Okay, so yeah, what will we study today? So we are doing states of matter right now. What are we doing? We are doing states of matter right now. Okay, and today we will be doing some questions what we have done till now. We will discuss all those important questions. Okay, we will discuss all those important questions. Okay, so that's what we will be doing today. Cool. Let me forward it. Yeah. Now you will see that the link for the class is given in the description box, and you can join the Telegram channel. There you will get all the updates of the class, of the basically of the YouTube class. Okay, and for my channel you can find me on Instagram as Kirti_Sharma. On Telegram as well as Unacademy Messenger, you can find me as Kirti_Sharma 1223. This is my username, and you will find me almost everywhere. If you search it from like this username, you'll find me. Okay, so you can join the Telegram group, my Telegram group, on which like I notify you guys regarding the special class and plus class. Okay, since you know already that this is you are watching right now the class on YouTube, and we have a small target for now, that is of 1000 subscribers, and I'm hoping that you guys will subscribe right now, you will follow, you will subscribe for this content. Okay, now let's get started with our questions. Okay, let's get started with our questions. So now the very first question is like, what we are doing is states of matter, right? It is states of matter. Let's write it. States of matter, and this is our, you can say, PSS. Okay, this is our problem solving session. This is our PSS, problem solving session. All right, now the very first question says, what are the forces of attraction and repulsion between interacting molecules known as? कि जो force, like the one which is acting between the interacting molecules, we started from it, right? And now you guys need to tell what is the name of that force. It is attractive forces, repulsive forces, intermolecular forces, or intramolecular forces. All right, which one of them is there, like it is present? Okay, so yeah, tell me, you guys take a moment and read the question. See, I always tell you the very first step in order to solve the question is to read the question carefully. If you, like, sometimes what happens is you don't even read the question, so that is like where your primary mistake lies. Okay, so yeah, tell me, what are the forces of attraction and repulsion between interacting molecules known as? Attractive forces, repulsive forces, intermolecular forces, or intramolecular forces. So we know that we have already discussed the intermolecular forces are the forces of either attraction or repulsion between the interacting molecules, or you can say atoms as well. Okay, so that's what you can say. Now, with intermolecules, we discussed that if these are two molecules, say if it is your dipole interaction, so we know that at this end here will be some delta positive charge, here will be some delta negative charge. Suppose if this is HCl, okay, dipole forces. So because of this negative force at the left end of the other molecule, here some delta positive charge will be generated, and here will be some delta negative charge, right? So now this force has been established between two different molecules. But what is intramolecular? Intramolecular is when forces are like acting like within the molecule itself. Okay, so here you can see that intermolecular means between molecules, and intramolecular means within the molecule. So this is something to remember, that intermolecular means between molecules and intramolecular means within the molecule. Both attractive and repulsive forces include intermolecular forces. Therefore, the force of attraction and repulsion between interacting molecules is known as intermolecular forces. That is why we said that option number C is correct here. Is that okay, guys? I believe that there is no doubt in this particular question. Okay. Next question. It says London force is also known as. See, what we discussed, we studied what are intermolecular forces in the first place. What we saw in the first place, it was intermolecular forces, right? Then we saw that these forces can be attractive as well, these can be repulsive as well. Okay, these forces can be attractive and these forces can also be repulsive in nature. These forces can also be repulsive in nature. The attractive intermolecular forces, we named them as what? We named them as Wonderwall forces. We called them as Wonderwall forces, right? So that's what we did. So attractive intermolecular forces, you named them as Wonderwall forces. We did not discuss about more about repulsive forces. And then we know that there are three types of attractive intermolecular forces, that is Wonderwall forces. The first one is, we studied London force. There is another name for London force as well. In the second place, we did dipole interaction या dipole forces आप कह सकते हो. This is dipole force. And the third one that we did was dipole induced dipole. It was dipole induced dipole. Okay, so I believe that this story is clear. Intermolecular forces, the forces of attraction or repulsion between the atoms or molecules, and it does not exist in ions. It does not exist in ions. Does not exist in you can say covalent bonding. In covalent bonding and in ionic bonding as well, or in ionic bonding as well. Okay, so it does not exist in covalent bonding and in ionic bonding, because you know already that in case of ionic bond, the force of attraction between the ions, that is a positive charge and a negative charge, it would be what kind of charge? It would be electrostatic force, right? It would be electrostatic force. Okay, so I believe that there is no doubt till now. Let me know beta if there is any doubt till now. Okay, and if you guys are planning to take the plus subscription, then you can take it. Don't forget to use my code, that is Kirti S Live. My code is Kirti S Live. Okay, so you can use my code if you want to get plus subscription, and you will get an additional 10% discount if you use this code. And I have one more interesting thing for you, that is, you can see here, for ICSE board students for class 9 to 12, there is an offer for plus subscribers, and it will be ending on 31st of January. Okay, if you get plus subscription for 12 months or above, you will get an extra K12 subscription for for extra 3 months you will get. Okay, so if you get it for 12 months, you will have the subscription for 15 months. Okay, so this is again a very pretty deal that you can avail, right? That you can take benefit of. This is amazing, and it is only valid for first 500 subscribers. So make sure you are in the first 500. Okay, don't lose this chance. All right, very important for you. And when you get the subscription, don't forget to use the code that is Kirti S Live. My code is Kirti S Live. It is the code. Is it okay, guys? So let's move ahead. Let's do next question. Yes, so we were doing this question which was saying that London force is also known as, what was the another name for London force? It was dispersion force, right? London force इधर भी लिख लेते हैं, or you can say dispersion force. That's why I'm writing it later on. It is your dispersion force. Okay, let me know, guys, if there is any doubt. All right, let's move ahead. So here is an explanation for you which says that electrically symmetrical atoms and non-polar molecules having zero dipole moment due to their electron distribution may sometime develop a momentary dipole, also known as London force or dispersion forces. So if you guys have any doubt in the Wonderwall forces, like in the attractive intermolecular forces, go and watch the previous lectures. Okay, because see, we start every chapter from the basic, correct? So you should have, like, you will have a proper idea like what is going on in the chapter. All right, guys, I believe no doubt till now. Next question. Now, in this question, a lot of students answered incorrectly. A lot. I asked this question earlier as well. So, like, in order to make you understand such that you don't do the same mistake again, that's why I added the same question, which says dispersion forces interaction energy is proportional to. So we know that in case of dispersion force, take a moment or two, think about it, and let me know what will be the answer of this question. Okay, tell me, guys. जो डिस्पर्शन फोर्सेस के केस में इंटरैक्शन एनर्जी होती है, इट इज प्रपोर्शनल टू व्हाट? Just give me a moment, guys. Is it okay? Yeah. So it is your dispersion. So we discussed, what we discussed, that your dispersion forces interaction energy is proportional to. Although we discussed that dispersion जो interaction energy होती है, we discussed that interaction energy is inversely proportional. It is inversely proportional to the sixth power of r. Inversely proportional to the sixth power of r, where r is the distance between the two molecules, to the sixth power of r, right? That's what we know. Now the same thing can also be reframed as, the same statement can be reframed as that interaction energy. From here, like, you mean that interaction energy is inversely proportional to 1 by r raised to power 6. But the same statement I can make it as that interaction energy is directly proportional or simply proportional to 1 by r की power 6. So you can say the same thing, right? This is interaction energy. It should be IE. To be more precise, let's write it as IE. Okay. Okay. It's not ionization energy here. Here we are talking about interaction energy. So the same thing can be said in two different ways, that either your interaction energy is inversely proportional to r raised to power 6, or else you can say that interaction energy is directly proportional to 1 by r raised to power 6. So here we have been asked it is proportional to, not inversely proportional. So the answer will be 1 by r raised to power 6. Okay, sometimes all we know is that it is inversely proportional to r raised to power 6. So you don't even consider the option that it is proportional to 1 by r raised to power 6. Okay, these are two different things. Please make sure please make sure that you know this difference. Okay, if you don't, if you have any doubt, then simply let me know. Okay, let's move on to the explanation, which says that answer is option number D, right? That's what we marked, which says that interaction energy between two atoms or molecules experiencing dispersion or London force is inversely proportional. Again, the same thing in two different ways. It is inversely proportional to the sixth power of the distance between those molecules when found experimentally. Now this is totally a data which is based on experiments, right, which you found by experimenting. So the next thing is HCl is an example of. Tell me, what kind of molecule, like what kind of interactions, what kind of forces occur between like HCl molecules? Tell me. Dipole-dipole interactions, although we have discussed the same example, right? Dipole-dipole interactions, dipole-induced dipole interactions, London interaction, or simply or Wonderwall interaction. Tell me, what will be the answer? Tell me, Bacha Party, you are available here na? Tell me, what is the right answer? So you can say that HCl, we know that polarity exists, dipoles are created, right? That is why HCl is an example of dipole-dipole interactions. Is that okay? Is that clear? Okay, guys. Let's move ahead. So here you can see the explanation, which says dipole-dipole interactions occur between molecules having permanent dipoles, okay? And also the ends of dipoles possess partial charge, which represented by a Greek letter delta. Okay, so in an HCl molecule the same types of interactions occur. Same explanation that we just discussed. Okay, here you can see some of the features that we have for you on the app, that is poll, raise a hand, ask a doubt feature, which is 24/7 available. Okay, next, so the process in which the solid changes directly into vapors. Your solid is directly changing into vapors. Alright, so what do you call this process? What this process is called when solid is directly getting converted into vapors without passing through liquid state. Without passing through the liquid state. So yeah, tell me. It is condensation, evaporation, boiling, or sublimation. Tell me, guys, what will be the right answer? So we know that whenever a solid changes into vapors without passing through the liquid state, it is called as sublimation. What do you call it? You call that process as sublimation, and that substance is termed as sublime. Okay, the best example that we have already discussed in the previous classes is of naphthalene balls, right? वाइट कलर की बॉल्स होती हैं हिंदी में इफ़ यू हैव हर्ड दे आर कॉल्ड एज फिनाइल की गोलियाँ ओके so if you put it in your cupboard or like just on floor for some time, they are usually put in the cupboards or cabinets so that like there will be no pest, okay, like though no cockroaches, no mosses, and like no rats and stuff. There will be no pests that can enter because the vapors are a bit quite poisonous, that if the like they eat them, they die, okay, or they cannot grow inside that vapory atmosphere. Is that okay? So the naphthalene balls are the example. If you don't know, ask your mom. Chances are she'll let you know, okay? Whether in Hindi or English. Naphthalene balls, या फिर you say it as Hi Kevin, I am good. Nice name. मैं अच्छी हूँ बेटा. I am pretty good. You say what's up with you? Alright, so it is called as sublimation when solid directly changes into liquid, into vapors without passing through a liquid state. Alright, now the next question. Look at this question and let me know what will be the answer. So it says that a balloon is filled with hydrogen at room temperature. So like it is saying that it will burst if the pressure exceeds by 0.2 bar. कि अगर उस balloon के अंदर, if inside the balloon the pressure exceeds 0.2 bars, if the pressure is more than 0.2 bars, then simply your balloon will burst, okay, it will pop out. So if like in general, now this information is given to you, like generally what happens, the 1 bar pressure, if at 1 bar pressure the gas occupies 2.27 liters, when your pressure is 1 bar, at that moment your volume is 2.27 liters. So we have been asked up to what volume can the balloon be expanded. I'll give you options as well, okay, or simply let's just solve it, okay. If like you can solve it, we have done the same question earlier as well, okay. So see, what can we do? We can say that when your pressure, say P1, say when your pressure P1 initially was how much? It was 1 bar, okay, and your volume V1 was how much? It was 2.27 liters. It was 2.27 liters, okay. Now if like when we talk about the pressure inside the balloon, finally we have been told that when the pressure is P2, say its value is 0.2 bar, right, inside the balloon. So it is the maximum value of pressure that can exist in the balloon, inside the balloon. So at this point, what will be the volume V2? That's what we need to find out, right? That is what we need to find out. So what can we say? Tell me. What can we say? We know, like we can see that this is a pressure volume relationship. So we know that according to Boyle's law, that is your pressure volume relationship. It is your PV relationship, right? So what happens in case of this? You know already that P1 V1 is equal to P2 V2. We have already derived it. We have discussed like how this thing comes up. So you can say here that P1 V1 is equal to P2 V2. ठीक है? Let's put the values. Although we know that we need to find the volume V2. We need to find volume V2. Its value will be how much? It will be P1 V1 over P2, right? It will be P1 V1 over P2, right? So if you simply put the values, you will get the value of V2. P1 is 1 bar, V1 is 2.27 liters, right? And P2 is how much? P2 is 0.2 bars. So when you solve it, it is 2.27 over 0.2. It will come out to be around 11.35 liters. How much it will be? It will come out to be 11.35 liters. Okay? So this is your final answer. Okay? I believe there is no doubt in this particular question. If you have, then simply let me know what is the doubt and we will get it sorted. Alright, now let's move ahead. Now, in comparing gases with liquids, when you compare gases with liquids, gases have dash compressibility and dash density. So we have already discussed this in the very first lecture. In the very first lecture, we have already discussed this. So we know already that when you compare gases with liquids, we all know that gases are the most compressible. We know what? Gases are the most compressible. They are the most compressible. We also know what is the meaning of compressible. If you take a cylinder, say if it is your cylinder, all right, and here are say some gases which are present in this cylinder, okay? Like these are the gaseous particles which are present, okay? If you apply a piston here, say you applied a piston here this way, okay? Okay, now if you apply some pressure P here and you are trying to drag the piston down, so what will happen? You will see that, ma'am, this will be let's make it here, maybe you cannot see it over there. So what can you say? You will see that the gases will be they will be here in a smaller volume, right? When you apply some pressure on the molecules of gas, right? So it will be something like this. When you applied the pressure, so your the same number of particles which were present in this volume, now they are present in a smaller volume, right? So you call this as compressibility. What do you call it as? You call it as compressibility of gas. What do you call it? You call it as compressibility of gas. Is that okay, guys? That's what you call them, compressibility of gases. So in comparing gases with liquids, gases have a greater compressibility. We can see here the options. So according to them, we can say that gases have greater compressibility. And if we talk about density, so we know that density का order क्या होगा? Solids are the most dense, means the particles are compact, the particles are close together. Solids, then liquids, and in the end gases. Okay, this is the order for density. This is the order for density, right? So we can say that in comparing liquids, gases have greater compressibility and smaller density. And smaller density. That's what you can say. Let's write it again in a proper manner. So you can say that gases have greater compressibility and smaller density. Okay, so this is the right answer. What will be your right answer? It will be greater comma smaller, right? It will be greater comma smaller. So if we look at the first option, it says that it is your greater comma smaller. Okay, I believe there is no doubt in this. I have already told you there is a very amazing offer for plus subscribers for class 9 to class 12. This offer will end on 31st of January, and this is only valid for first 500 subscribers. If you get the plus subscription for 12 months and above, you will get subscription for you will get free subscription for extra 3 months. Okay, so this is again a very amazing deal. All right, bacha party. What else we know that for class 11 and for class 12, a new batch is getting launched on 17th of January. Okay, the name of the batch is Mavericks, and I love this name because like Mavericks is a bird. Okay, Mavericks is a bird, as well as like an independent person as well. Okay, so that is why the name of the batch is Mavericks. It is an all subject batch in which like delivery is going to be in English, and moreover again a very amazing subscription, like a very amazing offer for you. That is, if you subscribe for ISC class 11, you will get class 12 subscription for free. Okay, so this is something amazing, and like if you get it for 12 months, you will get extra 3 months as well of the subscription. So like you are getting multiple advantages of getting the plus subscription. So I would suggest you to get it right now. Okay, because this is just for a limited period of time. After this you might have like you might lost it. Okay, so yeah, in this batch, Sanam sir is teaching you maths, I will be teaching you chemistry, and Saurav Verma sir is teaching you biology. All right. So don't get delayed, and don't delay it, and enroll in the plus subscription as soon as possible. Moreover, you can use my code, that is Kirti S Live. The code is Kirti S Live, and you will get an additional 10% off when you use this code. Okay, so I believe it is amazing. Please note, it is not Kriti, it's Kirti, Kirti. Okay, next thing that we have for you is like the same batch, Mavericks batch for class 12. Okay, for class 12 as well. Okay, and the same things are valid here, that the delivery is going to be in English, teachers are same. If you subscribe for class 11, you will get a class 12 subscription for absolutely free. Okay, so I am telling you again, there are multiple offers you can take advantage of. Like subscribe for class 11 and you will get class 12 subscription for free. Okay, and and use the code KirtiS Live, you will get an additional 10% off. And get it for at least 12 months, so that you will get additional 3 months free. So this is a full on package for you. Okay, you are getting multiple benefits. Okay, multiple discounts you are getting. So this is an amazing deal. So I would suggest you to, get the subscription as soon as possible. Okay, very cool this is. Let me tell you, like, there are, what are the multiple offers? I'll let you know. Like, the very first thing is subscribe for class 11. Okay, the very first thing is subscribe for class 11. Now what will happen because of this? You will get class 12 subscription for free. You will get class 12 subscription free. Okay, this is the first offer. You will get basically you will get class 11 plus class 12 subscription, okay? This is done. Now you subscribe for at least 12 months. For example, if you subscribed for 12 months, okay? Say if you subscribed for 12 months, so if you do it now, you will get 3 months extra free. You will get 3 months free extra. So this is another thing. And when you apply the code, that is Kirti S Live, the code is Kirti S Live. So after all this, getting class 11 subscription plus class 12 subscription and plus 3 months free, and when you apply this code, you will get additional 10% off. You will get additional 10% discount. So this is an amazing deal for you. All right, I would suggest you to get the plus subscription right now, right away. Okay, this is something very amazing for you. Is that clear, guys? Now let's move on to the next question. So you can see here the explanation of this question, the compressibility and density wala question that we just did. So it is saying that in a gas, we have done this, we have just discussed the same thing. So it is saying that in a gas, the distance between molecules, whether your gas is monoatomic or polyatomic, is very large compared with the size of molecules. Thus, gases have low density and they are highly compressible. Okay. We know that the molecules of a liquid are packed relatively close together. So, consequently, liquids are much denser than gases. Okay. Next. Where is my pen? Here it is. So, yeah. Next question is, a gas has a volume of 3.86 liters at a temperature of 45 degrees Celsius. Just give me a moment, guys. Just give me a moment. Yeah, let's get back to the question. Yeah, so the question says that a gas has 3.86 liters of volume at a temperature of 45 degrees Celsius. So I have told you multiple times, like whenever it comes to temperature, then always take temperature in kelvins. Always deal with temperature in kelvins, not in degree Celsius or in Fahrenheit. Okay, don't do this. Okay, you always use it in Kelvin. Okay, always use it in kelvins. Now, so the very first thing is, we will First convert this 45 degrees Celsius to what? We will convert it to tell me, just a moment, in Kelvins, right? What happened? Yeah, that's what you can say. So what will the volume of gas be if its temperature is raised to 80 degrees Celsius while its pressure is kept constant? So let's write, okay, what we have been given here. We have been given that your volume V1. Okay, initially your gas has a volume of 3.86 liters, right? When the respective temperature, say T1, was how much? It was 45 degrees Celsius. Now I told you, do not deal with temperature in degrees Celsius, deal it in Kelvins. So like you will add 273.14. So 45 plus 273, okay? Now this has this is now in Kelvins, right? So it will be 318 Kelvins, right? So now that's your final temperature. That's what you will take as temperature. Now your volume V2. Now your volume V2 is what we need to find, right? We have been asked what will be the volume of the gas if its temperature is raised to 80 degrees Celsius. We need to find V2 when your T2 temperature is how much? 80 degrees Celsius. So 80 degrees Celsius, again we will convert it into Kelvin. So 80 plus 273, that's what you will do, right? And it will come out to be 353 Kelvin, right? It will be around 353 Kelvin, correct? So now you have your temperatures in Kelvin. So we know now, according to your Charles law, that's your volume temperature relationship. So you can say that according to Charles law, that is your volume temperature relationship. It is your volume temperature relationship. So you know already that V1 by T1 is equal to V2 by T2. Okay, this is equal to V2 by T2. Is that okay? So simply let's put the values, and we know that we need to find the volume V2, right? We need to find the volume V2. So it will be equal to, so it will be V1 into T2, if you send this T2 here, by T1, right? Simply put the values and you will get your answer. From here, V1 into T2 by T1 will be equal to V2, right? So from here you can say that your V2 will be equal to, V1 is how much? 3.86 liters. How much is your temperature T2? It is T2 is 353 Kelvins. 353 by T1. T1 is how much? 318. So over 318. Alright. So when you solve this, you will get the answer, and it will come out to be around, I believe, 4.28, right? As we can see here, it will be around 4.28 liters. That's your option number B, which is the correct answer. Is that okay, bache? Let me know if you have any doubt. Do you have any doubts? Just simply let me know. Okay, here we have done this question, and I believe that there is no doubt in this. Cool. I can see myself. No doubts till now, right? That's great. Let's move ahead. So the next question says, intermolecular forces can be out of the following. Option number A, Wonderwall forces. electrostatic forces existing between two oppositely charged ions, covalent bond between two like atoms, or gravitational force. So we know already that the attractive intermolecular forces, we made a like flow chart type thing as well. We know already that the attractive intermolecular forces, that the attractive intermolecular forces are also called as what? They are called as van der Waals forces. They are called as van der Waals forces. Is it clear, biche? So that is your answer. Option number A is your answer. So intermolecular forces can be out of the following. So we know already that intermolecular forces can only be van der Waals forces acting between two molecules. Is that okay? Any doubt till now? Just simply let me know in the live chat. Okay. Next question, which says conversion of a liquid to a gas at all temperatures. Simply like liquid to gas. What can be the simplest example? You had water. If you put it on the flame, it will get converted into water vapors, right? It will get converted into water vapors, so, right? So you call it as evaporation, right? Sublimation is solid to gas, evaporation is liquid to gas, condensation is gas to liquid. Okay, so we knew this already. Next question, which says van der Waals forces include the following except van der Waals forces में कौन से forces included होते हैं? That's what you need to answer. Tell me. London forces, dipole forces, dipole induced. It is not include, it is induce. Let's use black color. It is dipole induced dipole induced dipole forces or chemical bonding forces. So see, here we have been asked basically which one is not van der Waals force, right? So like sometimes when you don't read the question carefully, what you do is, oh, van der Waals forces include the following. Option number A, London forces. Yes, this is a kind of London van der Waals force. So you just simply tick on it, right? So here it becomes like incorrect, right? Because you have been asked which one is not London force. So we know that all these three are van der Waals forces, but chemical bonding is not. That is why this is our correct answer. Okay? I believe there is no doubt in this. You have understood this. Okay? So yeah, you can see here that van der Waals forces are distance dependent forces between atoms and molecules, not associated with covalent or ionic chemical bonds. I told you this already. Sometimes the term is used to encompass all intermolecular forces, although some scientists only include London dispersion force, Debye force, and Keeson force. We will discuss it later on, like what these kinds of forces are. Debye force and Keeson force. Okay? Yeah. Next question says, at a constant temperature, the pressure of a gas is given as 1 atmospheric pressure. And like when your pressure was 1 atmospheric pressure, 1 atmosphere, then the volume was 5 liters. So when the atmospheric pressure is increased to 2 atm. So basically, see, very simple question this is. When your pressure is doubled, right? Initially it was 1 atm and now it has been doubled. Means later on, finally it is your 2 atmosphere. So we have been asked what will be the volume of the gas at that point. So if your initial volume was 5 liters, so quite obvious that if pressure is doubled, then volume is reduced to half, so that the product of pressure and volume will remain constant, right? So that this value will remain constant, correct? Or like some other way, obviously you can do it by Boyle's law, that is P1 V1 is equal to P2 V2. ये तो हमेशा है ही, right? So when your P1 initial pressure was 1 atm, then your volume was 5 liters. When your pressure was 2 atm, so we need to tell what will be the volume V2 at that point. So we know that V2 will come out to be 5 by 2 liters, and we know what is the value of 5 by 2. It is 2.5 liters. It is 2.5 liters. Okay? So when your pressure is doubled, your volume will be reduced to half. You can do it in that way as well. So simply you could just tell that it will be 2.5 liters. Okay? So 1 liter, no. 5 liters, no. 10 liters, no. 2.5 liters, yes. That's our answer. Okay? Any doubt in this, bache? Just simply let me know if there is any doubt. Here you can see it is the answer. Alright? Let's move on to the next question, which says, what is the shape of the graph that is drawn between pressure and volume? So we know that pressure and volume are inversely related, and whenever two quantities are inversely related, the graph comes out to be something like this, and this shape is called as hyperbola. Let's draw it again. This shape is called as hyperbola. What do you call this shape? You call it as hyperbola. Okay, that is your option number D. So it is your correct answer. Okay, you know this already. What is the volume? What is the name of the graph that is drawn when the temperature is kept constant? I told you already that when temperature is constant, when you keep temperature constant, the graph that is drawn, we are talking about the graph here, the graph is known as isotherm. If you keep the pressure constant, if you keep pressure constant, in that case the name of the graph is isobar. When your temperature, pressure, when your volume is kept constant, when your volume is constant, it is named as isochoric. Okay? It is called as isochoric or isochore simply. Okay? In that case, it is your isochoric. So what is the name of the graph that is drawn when the temperature is kept constant? It is isotherm. Okay? So I believe there is no doubt till now. Okay? Now let's this we know already about the batches, correct? And what else do we need to know? We need to know about the Unacademy subscription features. So like as we know, again there is an outbreak of COVID outside, so it's better to just stay at home and learn live, with the comfort of your home, with like top educators of India, right? So it's amazing. And when you get plus, all your doubts will be cleared, because every fourth session is a doubt clearing session. Okay, so you can say that there is an exhaustive coverage of the syllabus. Since we are here for you, you are the focused students, so we have we'll give you our mentorship, our guidance to you. Study material will be provided to you in the PDF format. Practice tests will be there. Everything will be there. So you can see that here are some of the prices of the plus subscription. And as I told you, get it for class 11, you will get class 12 subscription for free. Subscribe for at least 12 months, for at least 12 months, so that you will get additional 3 months free. And when you apply my YT code here, that is Kirti S Live. My code is, again, you know already, it is Kirti S Live. If you apply this YT code here, then you will get additional 10% discount. Okay, so it is amazing for you guys, and go for it, right? You know already that the batches have already been started, and you can see here, if you get subscription for class 9, you will get class 10, 11, 12 subscription for free. And my code is applicable all over Unacademy. So like in whichever category you want to take subscription, you can take this code. That is Kirti S Live. So don't forget to use this code. Okay, you can see these are the batches. Champion batch, which is going on right now. You can watch my special class and download the Unacademy app now. That is it for the day. Don't forget to use the code as usual, that is Kirti S Live. And if you want to like reach out to me, you can do that with the, like, this is my username, that is Kirti underscore Sharma 1223. Take care. So you can reach out to me on Unacademy Messenger or Telegram by this username. That is it for the day, guys. Bye bye. Take care, and wear your mask. Keep yourself vaccinated. Bye bye.